everybody. So for your asynchronous day work, you are going to fill these notes. We are at 5.1, the absolute value function day 3. This is the packet that you all have. It's the tan looking packet I gave you, and we talked about this yesterday. Day 3, so you are to follow along and fill these notes and then complete the homework. Okay, I will check that tomorrow when you come, the notes and the homework. All right, so let's get started. So continuing on with the absolute value function that we started yesterday. So let's look at this problem. We have J rides in a boat from his home to his friend's home in a neighboring state. The graph of the function d of t equals 30 times the absolute value of t minus 1.5 shows the distance of the boat in miles from the state line, so from the border, at t hours. Okay, assume the graph shows J's entire trip. Okay, the absolute value function here, the distance, this is the graph that it represents. So this graph goes with this equation. Okay, and then the distance here, as they said, is the miles from the state line, so from the border. Okay, so it's the distance from the border. All right, and then we assume this entire graph shows J's entire trip. Okay, and here's the picture. So it looks like Jay is in Arizona. He lives in Arizona. That's the boat. He gets in the boat, and he goes towards Utah. So that's the border line. Then he's going into Utah. So let's take a look at the key features of this graph. How do the key features of the graph of the distance, or dt, relate to J's boat ride? All right, so if you look here at the beginning, so at time 0, this is the distance in miles. We are 45 miles away from the border. That tells me that Jay lives in Arizona and he's 45 miles away from the border. He was 45 miles away from the border in Arizona. Okay, so let's look, we're going to use t for hours as indicated here. So instead of x, we're using t. So let's look at the chunk of the graph from 0 all the way to 1.5 hours. It looks like the graph is decreasing, right? Going down. From 0 to 1.5 hours, the graph is going down, which tells me Jay gets in the boat. He's 45 miles away. He gets in his boat, and he drives towards the border. Okay, so the function is decreasing, so he's moving closer to the border. Okay, function is decreasing. So he's getting closer to the border. So he's moving. He's moving closer to the border. Okay, then here, after 1.5 hours, this is the vertex. So the vertex, after 1.5 hours, he reaches the border. Okay, J's distance from the border is 0. See, the distance is 0 because he's at the border. Okay, so at the vertex, which is 1.5 hours, 0 distance, okay, J's distance is from the border is 0. So he's at the border. Okay, then he crosses the border and he gets into Utah. So at the time, from 1.5 hours, okay, 1.5 hours to 3, he is in Utah driving towards his friend's house. Okay, so the function is decreasing. It's going, or excuse me, the function is increasing. It's going up. It's increasing. So from t at 1.5 hours to 3, the function is increasing. So he's going away from the border. Okay, moving away. He's moving away from border. So the distance from the border is going up. because he's moving away from it, going towards his friend's house. Okay, how far does Jay travel to visit his friend? Well, Jay traveled 45 miles to get to the border, and then he traveled again 45 miles to get to his friend's house. So the total trip is 90 miles. Okay, so 90-mile total. Okay, how does the graph show the domain and range of the function? Well, the domain and range, because this is a real life situation, so the domain is his time. So the domain refers to the time here. And the entire trip, you know, it's from 0 hours, of course, before he started moving on the trip, all the way to 3 hours. Okay, so the trip took 3 hours. That's the domain. The entire trip is 3 hours, 0 to 3. See? The x is 0 to 3. The range is the distance from the border. Okay, the range is the distance from border. Okay, so the distance one way is going to be that d. We're going to go d for distance. Okay, it's 45 and then 0 to 45, because that's half the distance. Okay, that's half the distance of the entire trip. Okay, one way is 45. All right, the other part of this video is the rate of change. So you already know, the good news is you already know how to calculate this actually really well. You should know how to do this really well. So the rate of change is another word or another name for slope. Okay, hopefully you recognize this. It's the change in y over change in x. y2 minus y1 over x2 minus x1. Okay, it's the slope. Okay, we are referring to it here in the absolute value function because sometimes we want to look at the rate of change in a chunk of the graph. Okay, as in this example. So let's look at this example. The graph shows Jay's boat ride across the state line. What is the rate of change over the interval 2, so the hours, the time between 2 and 2.5 hours, and what does it mean in terms of the situation? So we're looking at just this chunk. I want the slope between these 2 points is what we're looking at. Find the slope between these 2 points. Okay, and what does it mean in his trip? Okay, it says the section of the graph is a straight line, so the slope is constant, and the slope should be positive here because we're going up. Okay, that's what we expect. So we need to figure out the point. At 2 hours, so at 2, at t equals 2, because that's the time. Okay, the distance, I have to be careful with the scale here. This is going up by 5, 10, 15, 20, and so on. So the distance here is 15. So the point I'm looking at is 215. Let's write it as an ordered pair. That's my x1, y1. We'll make that one x1, y1. Okay, now the other point is right here. So at 2.5, at t equals 2.5, the distance looks like it is 30. So my x2, y2 is going to be 2.5 and 30. This is x2, y2. All right, calculate slope or rate of change. Okay, so I'm going to go rate of change, ROC, or slope. Okay, using this. y2 minus y1, so that's 30 minus 15 over 2.5 minus 2. All right, so that's 15 over 0.5, which is 30. Okay, what does it mean in context of the situation? It means he's going up. The slope is going up, so the distance is increasing as the time increases. Okay, it's going away from the border. The distance from the border is going up, is increasing as the time increases. All right? And then let's do this last problem. The same thing, just not a word problem, not related to this problem, just a different problem. What is the rate of change, or slope again, over the interval 15 to 18? So x between 15 to 18, as marked here. So I gotta find the corresponding y values, find the pairs. So it looks like at x equal 15, y is, this is going up by 1, so y is 3. Okay, so my point is 15, 3. This is my x1, y1. And then at x equals 18, right here, the corresponding y value is not quite 5 yet. Let's go 4.8. Okay, so the other point then is 18 and 4.8. This is x2, y2. All right, now calculate slope. So calculate slope, going back to this equation. y2 minus y1, so 4.8 minus 3 divided by x2 minus x1. So that's 18 minus 15. Okay, so that's 1.8 over 3, which is 0.6, or just 0.6. That is the rate of change over this interval. All right, that's it. That's a lesson. Go ahead and do your homework, your assignment, and we will see you tomorrow. Have a great rest of your day.